Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, dear students, boys and girls, mother, father at home. This is our first session, inshallah, of our e-learning. We're going to be having a revision of everything we've learned from the beginning of this term to the end of this term, inshallah. So let us go together. I hope each and every one of you are with your pens and your paper for whatever we're going to do now. It might come out from your exam, so take this revision seriously. Keynotes of questions in your exams will be discussed today. So we're going to look into from the beginning of the term down to where we stop in our classroom. So take this as another extension of our classroom. So can we start now? Everybody, please, your attention should be on the board. Welcome to the first edition of our e-learning. Wow, this is first term physics notes, grade 7, 2025-2026 session revision. So let's quickly go to the table of contents of the things we are going to be discussing this time around. Let's go together. Table of contents. From the beginning of this term, if you observe your notes, we are able to look at so many things, of which I will start with the definition and the scope of physics. After we discuss that, we move to the next one. We look at the branches of physics. And then we look at the possible careers in physics. Then we look at the applications of physics. We look at the relationship between physics and other sciences. Then we look at scientific method. After that, we equally look at measurement. Then we look at the definition of measurement, the instrument for measurement, and this is where we start in measurement. Now let's take the first one, which is the introduction to physics class. I need you to think from what we've discussed from our classes. Let us go ahead and think before I project anything here. Let's think. Ask yourself, what is physics? Why physics? Ask that question quickly, and then we move. When we say physics, let's go. The meaning of physics. Alright, the word physics comes from a Greek word physis, meaning nature. Physics is a branch of science that deals with the study of matter, energy, and interaction between them. So this deals with nature, matter, and interaction between these things. Now, look at the keywords here. Meaning. Look at this. We said the ancestral meaning of this is a Greek word. And the word is the ancestral meaning of the word, physics. And today in our 21st century, we refer to this physics as physics. As physics. And we say physics is a branch of what? Science. It's not a branch of art, but a branch of science that deals with what? The study of matter, energy, and interaction between matter and energy. Are we together? So let's take it once again. The word physics comes from the Greek word physis, meaning nature. Physics is a branch of science that deals with the study of matter, energy, and the interaction between them. Let's move on. Let's look at other definition of physics, since that is just an introduction. Let's look at the first one. Now, physics, another definition will say, physics is a natural science concerned with the study of fundamental laws. That's the first definition. Let's take it again. Physics is the natural science concerned with the study of fundamental laws of nature. Let's look at the second one. It says, physics is the study of matter. Not just matter, anything that has mass and occupies space. That is what we call matter. Anything that has mass and it occupies space. So we say it is the study of matter, energy, and when we say energy, we said the capacity to do work. So it is the study of matter, energy, and how they interact. How what interact? How matter, which is anything that has mass and it occupies space, how they interact with the energy you use, the capacity you use in doing that job. Are we together, class? So let's look at the third definition of physics. We said physics seeks to explain how and why things happen in nature. Now you're sitting down. Attention in the board. Watching what I'm doing here. Now, physics try to understand, why are you sitting down? Why are you paying attention? After this class now, you probably go eat, rest, probably sleep, or have fun outside. Why are you having that fun? That is what the physics is trying to tell us here. It says physics seeks to explain how and why things happen in natural world. Are we together, class? So let's move to the next slide now. How can we apply physics in our day-to-day activities? Now we're going to look at applications of physics. Applications of physics. Take your time to sound it. Application of physics. All right, let's go on. So, physics in our everyday life. How does physics affect you in virtually everything you do? Are you sleeping? There is physics there. Are you lying down? There is physics. Are you jumping? There is physics. So let's see how this physics come to play in our everyday life. Let's go. Physics is a part of our daily activities. Physics is a part of our daily activities. Example includes electricity, transportation. Let's take the first one, electricity. Switching on light, using phones, computers, appliances depends on the principles of electricity. Now, how many of us are at home and you will tell me you're not using your phone? You're using a gadget currently, watching me what I am doing. That is physics. So that is one area you apply physics. I will take it again. Physics is the part of our daily activities. Example includes electricity. How do you use this electricity? Switching on lights, using phones, computers, and appliances. All these depend on what? The principle of electricity, because that is the energy that is being generated to give us this. Let's look at the second one. The second one says transportation. Transportation. What are the things we use for transportation? We have car, we have train, we have bicycle, we have airplanes. Move based on the principle of motion and aerodynamics. Now, when we said they move based on the principle of motion, if you are in one place, you are in motion, but that type of motion is a motion in the place. But take example of a car. A car cannot just be in one place. A car needs to move from point A to point B. Same thing as the train. It needs to move from point A to point B. Bicycle, the same thing. Airplane, the same thing. So these movements are all aligned with the principle of motion. And when we're talking about motion, we're talking about movement from one place to another. Are we together? Are we together? I will quickly take it from the top. Physics in our daily lives. The first says, physics is part of our daily activities. Example include electricity. Switching on light, using phones, computer, and appliances depend on the principles of electricity. The second one says transportation. Car, train, bicycle, and airplanes move based on the principle of motion and aerodynamics. Let's move to the next one. More application, we only discussed two, so let's look at other applications of physics. Let's look at application based on communication. Application of physics based on what? Communication. What are the agents of communication? We have radio, we have television, we have mobile phones. Operate through electromagnetic wave. That thing that enables you to discuss with me from where you are to where I am currently now is what we call electromagnetic wave. Electromagnetic wave. For you to be able to call your mommy, your daddy from your sitting position outside, whether within the country or outside the country, you use electromagnetic wave. So, and if we're discussing electromagnetic wave, we're discussing physics. So this is another area in which physics can be applied. Let's look at the next one. Says health, X-ray, MRI, ultrasound scan, and laser surgeries are physics applications in medicine. Today, if you feel you're sick and they take you to the doctor, I'm having serious stomach pain. they will want to know what is really going on. A doctor can just not open your stomach to check what is right there, what is the problem. But instead of doing that, the doctor tends to use these electronic advanced technologies, the X-ray, the MR, the ultrasound, to check what is really going on in your internal system. You can see now we're discussing health, and physics has come into health. Physics is not just standing in the position of just motion. Now we are back to health. Physics is going as far as going into your hospitals, where doctors use all these machines in our day-to-day activities. Let's move to the next one, which is domestic life. Cooking with gas, refrigerators, and fans depends on the principles of war, physics. Now, today you cook, you light your match, and then you put your pot, and then your pot begin to heat, you pour water on your pot. All these things have to do with physics. The heat that is being transferred is transformed from one form to another. Let's move to the next one now, where you love to play sports. Sports. You know how to run, jump, kick, and throw. Obey the law of motion and mechanics. All these points, they are telling you areas in which physics can be applied in our day-to-day activities. Let us move on. Branches of physics. Physics is broad and divided into different branches. We have one classical physics. We have modern physics. Under this modern physics, we have things like mechanics, optics, etc., etc. So let's move quickly. More branches. We have electromagnetic, we have electromagnetism, we have thermodynamics, we have nuclear physics, we have astrophysics, we have geophysics, we have biophysics. All these are branches of physics. Go through your notes, all these things you will be asking your evaluation. Let's look at the possible careers. I read physics in my university. What will I turn out to be in future? Quickly. Now, if you study physics in your school as a career, this is the first thing. Look at yourself. If you see yourself, you see an engineer. So if you read physics, the possibility of you becoming an engineer is very high. Look at medicine. You can equally go to hospital, use all these MR machines we mentioned earlier. Then you see information technology. If you read physics, you are likely going to work in these areas. Let's move on. Space scientists. You want to travel to space? Go and read your physics. Energy sector. You want to work with a power distribution company? Read physics. Education and research. You want to be a professor of physics? You want to teach physics. Other applications include robotic, nanotechnology, telecommunication, defense, etc., etc. These are the areas in which you possibly finish from school and then you're going to see yourself as a professional. Let's look at the relationship between physics and all the sciences. Quickly, let's take the first one. We're going to look at chemistry. What is the relationship between physics and chemistry? It says, physics explains energy changes in reaction, atomic structure, and bonding. This is physics. Now let's look at the second one. Second one says biology. It helps in understanding body dynamics, blood flow, and medical images. Let's look at the third one, geography. Explain the earthquakes, volcano, climate changes, and weather pattern. Quickly. Other relationship, mathematics, engineering, computer science. All these, you have the notes. Please go through your notes, and then all these are further discussed there. Let's look at the scientific method. Scientific method. Now, let's read quickly. Science is the study of nature and the physical world around us that we have already established earlier. Scientists do not just guess as such. They do not just guess answers, they use systematic way of finding solution. This systematic way is called scientific method. So the systematic way the scientists use is called scientific method. And let's go. The scientific method is the step-by-step processes scientists use to investigate problems, answer questions, and discover new knowledge. Quickly. Steps now in scientific methods. The first step is observation. Careful watching of events, things, or processes using our five senses: seeing, hearing, touching, tasting, and smelling. Example: you notice that a plant placed near the sunlight grows faster than kept in the dark, than the one kept in the dark. That is one. Let's go. The next one is what? Asking question, identifying the problem. After observation, a question is raised about what you have noticed. Example: why does the plant near the sun grow faster? Now this takes us to the third one, which is hypothesis. Formulating hypothesis. What does it say? Hypothesis is an educated guess or a possible answer to the question. It must be testable. Example: plant grows faster in the sunlight because, underline this word, because sun helps them to make food. This is the reason now, hypothesis. Let's go to the next one. Number 4, experimentation. You've seen all this. Now let's go to the lab and experiment it. Quickly, this is the stage of testing hypothesis by setting up an experiment. Now, we have first independent variable, dependent variable, and the control variable. Let's go. What you change? Amount of the sunlight. Dependent variable is what you measure, growth of the plant. Control is what you keep. What you keep the same. The type of plant, amount, water, soil, etc. Example: place one plant in sun and another in the dark, while giving both equal water and soil. Quickly, let's look at the next one, recording and analysis. Let's see what it says. Data means the information or result you collect from the experiment. Data can be recorded in a table, chart, or graph. Example: measuring the height of the plant. Let's look at the conclusion. This is the final statement that tells whether the hypothesis was correct or not. Example: the experiment shows that plants in sunlight grows taller than the plants in the dark. Therefore, the hypothesis is correct. How? Now we've said the hypothesis is correct, then let's communicate it. How does the scientist communicate? Scientists share their findings through reports, presentation, books, journals, so that others can learn and build on them. Let's go quickly. Importance of scientific method. 1. It helps scientists to avoid errors and guesswork. It ensures results are accurate and reliable. It provides a clear step-by-step way of solving problems. It allows discovery to be repeated and confirmed by other scientists. Let's go. Let's see a simple classroom. We've done that quickly. Just go through it. You have it on your notes. Please go through this simple classroom experiment. You see observation. Some farmers with fertilizer have taller beans. Question now: does fertilizer affect the growth? Hypothesis: beans with fertilizer will grow faster than those without fertilizer. Experimentation. Now, plants 2 beans seed, one with fertilizer and the other without fertilizer. Data: measure their growth for 2 weeks. Conclusion: compare the result and see if the hypothesis is true. Communication. Now share the findings with your class. Let's go quickly. Now this is a new topic, and this is second to the last, if not the last topic we're going to discuss, and we've discussed in this class. So quickly, let's look at measurement. Measurement is an act of comparing an unknown quantity with a known standard unit. It allows us to describe objects and events in numbers, making science accurate and reliable. The 3 most basic physical quantities in our daily lives are what? Length, mass, time. The 3 basics are what? Length, mass, time. So let's move quickly. Let's see how this will be taken step by step. Now let's look at the definition of length. Length is the distance between 2 points. What's the unit for length? The SI unit for length is measured in meters. In brackets, M. M signifies meters. Other common units, we have millimeters, which is mm. We have centimeter, which is cm. We have kilometer, which is km. Let's look at how these things are being converted. 1 meter is equal to 1 centimeter, 100 centimeter, and 100 centimeter is equal to 1,000 millimeters. 1 kilometer is equal to 1,000 meters. Let's go quickly. Instrument for measuring length. We have ruler, meter rule, small distance, measuring tape, long distance, vernier caliper, very small object, micrometer screw gauge, thickness of a thin wire, odometer, distance traveled by a vehicle. Accuracy and error. Quickly, parallel error and occur when the eye is not positioned correctly while reading the scale. Zero error occurs when measuring an instrument does not read the zero at rest. To avoid error, take repeated measure and average them. Application of length measurement. Now let's say building our houses, tailoring, road construction, sport feet, market, etc., etc. Quickly. Number 2, mass. Measurement of mass. Definition. Let's go. Mass is the quantity of matter an object contains. It does not change with location, unlike weight, which depends on gravity. The unit for mass is what? The SI unit for mass is kilogram. Other units are what? Gram, ton, and milligram. How do you convert them now? 1 kilogram is equal to 1,000 gram. 1 gram is equal to 1,000 milligram. And 1 ton is equal to 1,000 kilogram. Quickly. Instrument for measuring mass. We have beam balance, spring balance, and electronic balance. We're going to see them. Differences between mass and weight. A mass, the amount of matter constant everywhere, measured in kg. Well, weight, force of gravity on the mass, change with location and measured in Newton. Let's look at the instrument for measuring mass. We have the beam balance. This is what a beam balance looks like. This is a beam balance. This is a spring balance. This is a spring balance. This is what a spring balance looks like. And then we have the last one, which is electronic balance. This is what electronic balance looks like. Quickly. Application of mass. Buying and selling of goods, determining dosage of medicine, transportation, checking the loads and their weights. Quickly. The last one is measurement of time. Definition. Time is the ongoing sequence of events the past, through the present, and into the future. The unit for measuring time, the SI unit is seconds. Other units are minutes, day, week, year. How do you convert them now? 1 minute is equal 60 seconds, and 1 hour is equal 60 minutes, and 60 minutes is equal to 3,600 seconds, and 1 day is equal 24 hours. Instrument for measuring time. We have stopwatch, we have pendulum, we have atomic clock, and the last one is the importance of measuring time, organizing our daily activities, sports. Yeah. Instrument for measuring time. We have stopwatch, clock, wristwatch, pendulum, atomic clock, and then let's look at the importance now. The importance of measuring time, organizing our daily life, sports. Then experiments in the laboratory, navigation, and space travel. Let's look at the importance of standard unit, the SI unit. It ensures uniformity and avoid confusion. 2. Help scientists communicate results globally. 3. Makes trade and commerce fair and accurate. Now, this is our prefix 1 in measurement. 1 kilo, we've discussed that. You see centimeter, a millimeter, micrometer, and estimated versus measurement. Estimates, the measurement, the significance figures, all this we've discussed that. Go through your notes and then you're going to find it interesting. Accuracy and precision and error. Accuracy, we've discussed that. Accuracy, precision, error. And let's establish the relationship between mass, length, and time. Many physical quantities are a combination of these three, e.g., speed, distance divided by time, force equal to mass times acceleration. These are called derived quantity.